Imagine walking into a workshop where every tool is in its place, the soldering iron on one bench, components in neatly labeled drawers, and wiring kits within reach. That's exactly what ESP IDF provides for your ESP32-C3 projects, a predictable and structured layout where code, configuration, and build instructions live in harmony. In this lesson, we'll explore how an ESP IDF project is organized, the main folder, kmakelists.txt, and SDK config file, and walk through the build flash monitor workflow. By the end, you'll know how to navigate a project, adjust configurations, and deploy code on your board with confidence. When you generate or copy an ESP IDF example, the folder may look simple, but every piece has a role. The root kmakelists.txt acts like a project registration form, telling the build system how to treat your code. The main folder is your playground, where your application logic lives. The second kmakelists.txt inside main defines which files get compiled. Then there's SDK config, which captures all project settings, everything from target chip to Wi-Fi credentials. Think of it like a project diary, written by menu config. This structure isn't optional. It's the backbone that makes ESP IDF scalable across hundreds of boards and projects. For ESP32-C3 projects, the main folder is where your creativity becomes firmware. Every project includes an app_main function, the entry point similar to main. In C, you can split logic into multiple .c or .cpp files inside this folder for clarity. For example, Wi-Fi_connect.c for networking and sensor_read.c for hardware inputs. The companion kmakelists.txt inside main tells ESP IDF which files to build and where to find headers. If you forget to register a source file here, it's like forgetting to give the compiler your blueprints, the build won't include it. The SDK config file is automatically generated when you run idf.py menu config. It's a plain text file, but you should never edit it by hand. Instead, treat it like a database of your project's DNA. It remembers that you selected ESP32-C3 as your chip, your flash size, and whether Wi-Fi or BLE are enabled. When you commit a project to version control, SDK config ensures teammates compile with identical settings. Change something in menu config, and the file updates instantly. Ignore it, and you'll quickly run into mismatched builds or hardware misbehavior. Once your code and configuration are ready, ESP IDF follows a predictable three-step cycle: build, flash, and monitor. First, idf.py build compiles your code, resolves dependencies, and generates binary images. Then, idf.py pport flash writes the firmware into your ESP32-C3 over USB. Finally, idf.py pport monitor opens a serial terminal where logs stream live from your board. Together, this cycle forms the feedback loop you'll use daily. Debugging sensor values, monitoring Wi-Fi, testing MQTT, it all starts here. The faster you get comfortable with this rhythm, the quicker you can iterate and improve your projects. Let's ground this in a real project. Suppose you're building a smart plant monitor with ESP32-C3. Your main folder might hold sol_sensor.c and Wi-Fi_connect.c. The main kmakelists.txt includes both, so the build system compiles them. In SDK config, you configure Wi-Fi credentials and choose ESP32-C3 as the target. Running idf.py flash monitor loads the firmware and immediately shows soil moisture values over serial. With this workflow, every change, whether a new sensor function or a tweak in configuration, can be tested in minutes. That's how structured projects evolve into production-ready solutions. By now you should see how ESP IDF keeps ESP32-C3 development structured and predictable. The main folder holds your logic, kmakelists files guide the build system, and SDK config secures consistent configuration. The daily loop of build, flash, and monitor is your lifeline for testing ideas quickly. Whether you're building a hobby project or scaling to production, mastering this structure saves time, reduces errors, and makes collaboration easier. From here, you can confidently edit, configure, and deploy ESP IDF projects with a clear mental map of how everything fits together.